operating on containers. Let's take a look at template class.cpp. We'll make a copy of it and paste it into our working project. Open it up in the editor, and I'm going to maximize it here so that we can see it. So this class, you'll notice at the top here I have an exception class, and that's explained actually in the chapter on C++ classes. And I'll show you how that's used, but this is the same class that's used there, and it's one that you're welcome to copy and use for yourself. This stack class here implements a simple LIFO stack. There's a much more complete version in the standard template library. I've created this simple version so we can see clearly how it works. So this will operate on objects of just about any type. And you'll notice that the class definition starts with the keyword template and a type name. And of course, the keyword type name, you may occasionally see this as the keyword class. And in this particular context, either one will work. And I prefer to use type name for this usage. And then the rest of the class definition is pretty standard. You'll notice that there's places like on line 23, line 27, line 28, where we use this T as a type. So that allows the compiler to substitute the type and to create a specialization of this class whenever it's used, of the particular type that's being used for. And in our implementation section, you'll notice that the function signatures are a little bit more complicated. They have to have the entire template, stack, parameter, string as the specifier for the class that these particular implementation functions belong to. You'll notice the constructor here on line 36 and 37, and you'll notice that same constructor here on line 25. So here it says explicit stack int, and when we come down and look at the constructor, we have template, type name, stack, and the type parameter before the : whereas if we had just a regular class that wasn't a template class, it would just say stack : stack. So you need to realize that you need that template and type name before each function definition, and then the name of the class, you also need to have the parameter type in the angle brackets. So you'll see the same structure there on line 44 and 45 for the push function, for the pop function on 50 and 51. And these actually return the type, and so you see how that is constructed, whereas the constructor doesn't return a type. Though the syntax for declaring these tends to be a little bit complex, the actual logic of it and the actual construction of these functions is incredibly simple. We have just a few function methods. The rest of them are actually defined inline, the isEmpty, isFull, top, and size. And then down here in main, we construct a stack of integers on line 58. We construct a stack of strings on line 74, and we run them through their paces. So let's go ahead and compile and run this. Press the big green compile and run button, and you can see everything compiles and runs just fine. And if we look at this, we start with the integer stack. We report its size. We're constructing it at size 5. If I try to construct this of size 0, I'll get an exception. Save that and compile and run. Just going to click this run in the background button there. You see it says terminate called after throwing an instance of E, invalid stack size. And if I come up here to my constructor, you see that we check the size, that it's greater than max size or less than 1. And if it is, then we throw this exception with the string invalid stack size. And likewise, if I make this too big, the maximum is 1,000. So I'll just make it 10,000. And if I save that and run it, I get the same result, invalid stack size. So we'll run it with 5 again. And if you just get this launching box, you can always click always run in background or just click the run in background button. That's just an Eclipse thing. So we construct a stack of integers. We report its size. And here at the top, it says size is 5. The top is -1. The top after our 5 pushes is 4. And it reports that it's full. And then we do this loop here while it's not empty. We pop them, and we can show their values as we pop them, 5, 4, 3, 2, 1. And then we go ahead and construct a stack of strings, and we do exactly the same thing. And it works exactly the same way with strings as it does with integers. Template classes are especially useful for manipulating containers of items where the logical manipulation is independent of the type, and that's why the C++ standard containers are written using templates. So let's delete our working file